Hello students, so I heartily welcome you in the video lecture series on structural analysis 1. So as you know, we were discussing about model 3, that is fixed beam. So in today's third lecture we are going to again discuss about prop cantilever with the help of some numerical examples. So objective of this lecture is that after completion of this period you would be able to solve prop reaction of a prop cantilever beam. Also you will be able to construct shear force diagram for prop cantilevers. So before going towards first session, let's recap what we have learned in previous session. So in previous session we have learned about prop cantilever, that it is the beam in which cantilever beam with additional support is provided at free end or in between the fixed end and the free end. So you are familiar about the prop cantilever. Can you define? Yes. Prop cantilever is a beam that is can be defined as a cantilever beam with additional support provided at free end or in between free end and the fixed end. So to calculate additional support we have discussed procedure and equations and reactions required. The deflection due to external loading is equated to the deflection due to prop. By using this concept we have obtained the equation for the additional reaction at the prop end, and also studied the problem and draw loading diagram based on the given condition of the problem. So let's start today's session. So we are going to solve a numerical on calculation of prop reaction, and also further we will solve a numerical in which we will see how to draw shear force diagram. So first of all, let's have this numerical. A cantilever beam of span 6 meter carries a point load of 15 kN at 2 meter from fixed end. If the beam propped at free end, determine the magnitude of the prop reaction. So what is the meaning of this example? What he has asked? Yes, it has asked that we have to determine magnitude of propped reaction. Just we have to find reaction based on the data. So based on the data, let's draw a loading diagram. So the span is given as 6 meter. You can see the span is 6 meter and free end is supported by a reaction or prop reaction, that is at B, and there is a point load in between fixed end and the propped end, that is of magnitude 15 kN at a distance of 2 meter from the fixed end. Now let this 2 meter distance be assumed as a L1 and overall span as a capital L. So we have to find the reaction at the free end, that is prop reaction, let it be P. So first of all, tell me the given data. Just we have discussed. Yes, span 6 meter. Point load is acting at a distance of 2 meter from the fixed end. Let W equals to 15 kN, and let us assume that reaction at propped end be P kN. We have to find this P. How to find? Yes. Let us assume that deflection due to point load at free end as a maximum deflection. We know at the free end in the cantilever deflection will be maximum. So we will just consider a cantilever subjected to point load in between, and the deflection will be maximum at the free end, and let it be Y max. So we know this Y max can be obtained as W into AQ divided by 3EI plus W into A square divided by 2EI into B. Here in our case, A is distance from the fixed end of the point load, that is we have assumed at L1, and B is nothing but total L minus A. Here A is L1, so by substituting the values, W is given as 15 kilonewton and L1 is 2 meter. L minus L1, that is 6 minus 2 will be 4. So by solving in the form of EI, we will get. So solve it. First solve this term and this term individually. Yes, we will get 40 by EI plus 120 by EI. So again by solving, we will get result as 160 divided by EI. Now we know at the propped end, deflection will be 0. That propped support will be act as a simple support, and we know that at simple support deflection will be 0. For this we have already discussed that the downward deflection due to load will be equals to upward deflection due to the propped reaction at the free end, and we know this propped reaction at free end is assumed as P, hence upward deflection will become W into L cube divided by 3, and W is propped reaction P. So by simply putting the values of span, we will get answer in the form of EI, that is 72 P divided by EI. Now by simply equating these two, upward deflection and downward deflection, we will get P, right? So let's equate. Downward deflection is maximum 160 by EI equals to upward deflection due to the propped reaction 72 P by EI. Now EI will get cancel, and by solving this we will get P equals to 222.222 kilonewton. Okay, सबका आ गया आंसर ये. Okay, you can solve like this for such type of numericals. Okay, let's move towards second numerical, in which we will discuss how to draw shear force diagram and how to obtain shear force calculation in different points. So here there is a numerical. A horizontal cantilever of span 5 meter carries a point load of 10 kilonewton, a distance of 3 meter from fixed end, and propped at free end. At free end there is a propped support or extra support is provided, which is at the level of beam. Find prop reaction. First of all, we have to find prop reaction. Just we have already solved in previous numerical. And one more thing in this numerical is that also draw shear force diagram. That's what it means, shear force diagram. Now you tell me what we have to do first. Yes, first we have to draw loading diagram based on the problem. So let's draw. Everyone have drawn like this. Span is 5 meter, distance of point load from the fixed end is 3 meter, and magnitude of point load is 10 kilonewton. Let us assume that this upward reaction at prop is P. Yes, we have did in previous numerical. Drawn? Okay. So let's solve. First of all, write given data. What is given? Span is 5 meter, point load is 10 kilonewton, at a distance of 3 meter from fixed end. Let us assume what? Prop reaction at free end as a P kilonewton. So by simply equating the upward and downward deflections due to propped end reaction and the downward loading, we can find the prop reaction. Now we know the downward maximum deflection Y max can be obtained as W into A cube divided by 3EI plus W into A squared by 2EI into B. Here A is distance of point load from fixed end 3 meter and B is span minus A, that is 5 minus 3 means 2 meter, and W is given as 10 kilonewton. We have to equate it with the upward reaction due to prop, that is WL cube by 3EI, and W is assumed as upward prop reaction, that is capital P, and phi is the span. So by solving this we will get. Solve it first. First of all, solve these terms individually and equate with it. Okay, we will get 180 by EI equals to 125 P divided by 3 EI. Now this EI is again get cancelled. We will get P, and magnitude of P will become 4.32 kN. Everyone got this answer? Note it down fast. So, as we have obtained upward prop reaction at the free end, now based on this reaction we can go for the further calculation for the shear force at different points. So let's go for the shear force calculation. So first of all, tell me what is meant by the shear force. Can anybody answer? Yes, it is the sum of the transverse forces acting on the beam at any section on either left or right side of the section which we have assumed. So we have to find the shear force at different points. Generally we will obtain at the point loads and at the ends. Okay, so first of all let's see the diagram. ये आपके डायग्राम है. This P we have obtained as 4.32 kN. Downward point load is 10 kN at distance 3 meter. So in between B to C portion there is no loading, and A to C portion there is no loading, and we know when there is no loading between 2 point loads in the beam, the shear force diagram will be a horizontal line. So let's first of all go for the shear force calculation. Now shear force at B, there is prop reaction. Let us assume upward as a positive. Just write to the section, we will assume as a upward positive, means shear force at B will be 4.32 kN upward. Between B to C there is no loading, it will be same or straight line B to C. Now shear force at C, that is equals to this upward reaction 4.32 minus this downward force 10, we will get minus 5.68 kN. This minus will be drawn below the baseline. Got it? Now shear force between A to C, again there is no loading, hence it is a straight line and there is no shear force. Now shear force will be of magnitude minus 5.68 in between C to A or AC portion. There is a straight line. Now shear force at A. Now how to find shear force at A? Yes, total downward force acting on the beam is 10 and upward direction is 4.32. Remaining will be the reaction at fixed end, that is 5.68, that is upward reaction. Okay, now shear force at exactly A will be equals to minus 5.68 plus 5.68, that is equals to 0, and diagram will be like this. 4.32, in between B to C there is no shear or there is constant shear 4.32 kN. At C due to point load 4.32 minus 10, we will get 5.68 or 5.88. Between C to A there is no loading, straight line of magnitude 5.68 or 88, that is negative below the datum line. At A, upward reaction will be directed and the net shear force at A will be 0 and diagram will be like this. Okay, hope you have understood. So in next session we will again solve numerical, in which we will see shear force as well as bending moment diagram, construction and their calculation. So let's summarize what we have learned in this session. What we have learned? Yes, we have discussed that how to find prop reaction, shear force calculation for prop cantilever, and also how to draw shear force diagram for a prop cantilever subjected to concentrated load in between the span. Now based on this, in examination it may ask some of the questions. So there is a question which frequently asked in examination. You may note it down. Analyze the propped cantilever beam with concentrated point load. And there is a numerical. Hope you can solve this. So today we will stop here. Let's see you in next.